My name is Ben Albert, and I was the group reporter for Group 1 for the Rankine cycle experiment. So this is the Rankine cycle. Starts with a pump, goes to a boiler, a turbine, and a condenser. But in this experiment, there's actually not a pump on the apparatus. So that would make sense as to why some of the numbers would be weird. This is the fuel flow rate versus time. So the boxes on the end are the steady state start and steady state stop. And the diamond in the middle would be my just point of steady state analysis for each graph. You can see the drop off from us starting to tighten the valve on the propane tank. And it stayed about 4.38 plus or minus 0.1 liters per minute for the whole experiment. Temperature versus time and pressure versus time of the boiler. So the temperature versus time fluctuated a good bit throughout the whole thing, but I picked just a point in the middle to be the steady state. It was going up and down about 0.1 degrees Celsius the whole time. And you can see the drop off at the end. Each graph has a drop off when we close the valve off. But yeah, and then the pressure was actually pretty steady the whole time at about 702 kPa, plus or minus 1. So the turbine, the inlet and outlet pressure, and the inlet and outlet temperature, I graphed them on the same graphs. The pressure for the inlet and outlet was pretty consistent the whole time. For the inlet, it was about 170 kPa, and the outlet was about 23 kPa. For the temperature, the inlet was about 128 degrees Celsius, and for the outlet, the temperature was slightly below 100 degrees Celsius and rose a little bit. But after my steady state analysis mark, it rose to about 103 degrees Celsius and stayed there until we cut the fuel off. So the amps and the voltage, and also the RPMs on the next slide, they all the graphs kind of look like this. So they kind of fluctuated at the beginning, narrowed down, and then they started fluctuating all the way to the end. For the current was at about 0.87 amps, plus or minus 0.02 amps, and the voltage was about 8.7 volts, plus or minus 0.2 volts. They're pretty similar, the graphs. The RPMs, you can see the graph looks just similar to the voltage and current graphs, so that they seem to be pretty proportional to each other. The RPMs were at about 2,220 RPMs, but it was fluctuating a lot, so plus or minus 20 RPMs from the data we recorded. And the recorded values, so atmospheric pressure is 101.325 kPa. The initial boiler fill amount, we filled it to 4.6 liters. The fuel flow, like I said earlier, was about 4.38 liters per minute, plus or minus 0.1 liters per minute. The boiler pressure was about 702 kPa, plus or minus 1. Boiler temperature was about 170.45 degrees Celsius, plus or minus 0.1 degrees Celsius. The inlet pressure was at about 170 kPa. The inlet temperature was about 128 degrees Celsius. The outlet pressure was 23 kPa, and the outlet temperature was 100 degrees Celsius. And the steady state condense amount, which I found by subtracting the values from the used water and the water we dumped out from the condenser, was about 745 milliliters. I found the uncertainty from just the resolution on the beaker that we had it in. And the boiler water use was about 2.75 liters. Now these calculations are very off. I forgot how to use steam tables and do thermal problems. So as you can see, by 600%, you know, they're pretty wrong. But this is the work I did. Like I said, I would trust the estimated values from the group leader more than these. But so what I got though was about 51 watts of heat out of the boiler. So from the gas flow rate, we got about 699 watts per liter of fuel. The work generated by the turbine, I got to be 0.279 watts. The efficiency of the generator, 2,687%. Pretty great. The heat flow out of the condenser, I got to be 43.464 watts. The condenser efficiency is 137%. And the cycle efficiency, I got to be 14.7%. And that's it.